Good afternoon, girls. Uh, Very few participants today joined, only 4 participants so far. Actually, scheduled to begin at 1 o'clock because I'm having some meeting with the principal. I had till 1 o'clock the meeting. That's why I'm little late in conducting the class. And I thought only for half an hour it will allow. So that's why I put the message, the class begins at 1:30. Okay, now it is already 1:37. Let us continue with the class. In the previous classes, girls, we have seen the first unit about curve fitting, and then third unit, that is numerical integration. Today I'm starting the fourth unit, girls. It is solutions of simultaneous linear system of equations. Okay, and already we had enough revision while doing the classes and also before the CA exams and after semester examinations. Because of this lockdown period, we were given now time to do the revision. Okay, so make use of these revision classes, girls. I am saying this is for our benefit only. And all the submissions, assignments that you are supposed to submit, please submit anytime. Any decision can be taken basing on your performance in this online sessions, and also submissions. They may give you your result also. That much serious you have to be. Pass on this information to every participant. And everybody, whoever is joining this class, it is recording. Okay, so please pass the information to everybody. Every day I'll be having class with you during our timetable period. Okay, I need not give you specially any information more than this. Now let us start the class. See, you are going to now see how to solve the linear system of equations using numerical methods. In your high school and in your +2, you learned how to solve a system of linear equations by different methods, algebraic methods and analytical methods, and you learned theory of equations also. Now what is the specialty again here is you are going to employ numerical methods of solving the given system of linear equations. So what do you mean by a linear equation? First of all, you know 3x plus 4 is equal to 0. It is a linear equation in one variable x. Suppose if I say 2x plus 7y plus 9z is equal to 0. It is a linear equation in 3 variables x, y, z. Okay. Here the variables are x, y, z and power 1, 1, 1. So the linear equations. So let me give you in detail a definition of linear equation in n unknowns. Okay. An equation of the form, say a1x1 plus a2x2 plus a3x3 so on plus anxn is equal to b, where x1, x2, etc. xn are unknowns, where a1, a2, a3, an and b are constants, is called as a linear equation in n unknowns. Okay, just now I told you, suppose if I say 2x plus 3y plus 4z is equal to 7, it is a linear equation in 3 unknowns where a, b, c are constants. Okay, so here we are considering an equation with the n unknowns x1, x2, x3 so on xn, and these coefficients and this right side, they are all constants. Likewise, you are not considering one equation, girls. You are going to consider a system of such equations, linear equations. Usually we take m equations. See, this is first equation, second equation, third equation, so on, m equations. This is called as a system of m equations in n unknowns, x1, x2, x3, etc., xn. So you are going to learn how to solve such a system of linear equations. You may be given linear equations in 3 equations, 3 unknowns, 2 equations, 2 unknowns, 4 equations, 4 unknowns. Not more than that. Okay. So you're going to learn how to solve such system of linear equations. First of all, solve means what? Solving the system of equations means you're going to find out the unknowns x1, x2, x3, so on, xn, which satisfy all these m equations. Okay, see, you're finding out unknowns x1, x2, x3, xn means solving all these, you will be getting the values of x1, x2, x3, etc., xn. And that is a solution of this system means every x1, x2, x3, etc., xn satisfy first equation, second equation, third equation, so on, m equations. So you're solving a system of equations means suppose there are n unknowns, you're going to find out all n unknowns, and all those n values will satisfy all these m equations simultaneously. Okay, so the values x1, x2, etc., xn satisfying these m equations simultaneously is called a solution of this system. Okay, so if at all the system is having a solution, we say that the system is consistent. And sometimes a system of equations will not have a solution. In that case, we say that the system is inconsistent. Okay, so you're solving the equations means you're going to find out the values of these unknowns which satisfy all the equations, and when you are going to get a solution of that kind, we say that the system is consistent. If the system has got no solution, then the system is said to be inconsistent. Okay, see here an example I took. Here I took a system of equations in m equations in n unknowns. Here, this is a system of 4 equations, 1, 2, 3, 4 equations in 4 unknowns. What are they? X, Y, Z, W. Okay, so we are going to learn how to solve a system of 4 linear equations in 4 unknowns. Means your aim is to find out the values X, Y, Z, W which satisfy all these 4 equations. So here, whenever you have a system of linear equations, you please write that in this matrix form, girls. And you know how to write this system in the matrix form. How? You please write the coefficients. See, first equation coefficients A11, A12, A13, A14 in the first row. Second equation coefficients A21, A22, A32, A23, A24 in the second row. Like that, you please write the coefficients in each row. And then here the unknowns, it is a column matrix x, y, z, w, and then right side constants. So this system of equations always can be written in this form called as the matrix equation, where this is called as the coefficient matrix, which we denoted by A, and this is a solution matrix, capital X, and the right side is the constant. This is again a column matrix, capital B. Okay, so remember, you'll be either having 3 by 3, 4 by 4, or 2 by 2 matrices only, because you will be solving the number of equations is equal to the number of unknown system. Okay, so here the number of equations is 4, number of unknowns is also 4. So now we are going to see how to solve such system of equations. Remember, when right side of this equations is 0, then we say that the system is a homogeneous system of linear equations. And when you, at least one of them, one of the B1, B2, B3, B4 is different from 0, we call it as a non-homogeneous system of linear equations. You will be having homogeneous and non-homogeneous. So, what are the methods to solve this system of linear homogeneous equations and linear non-homogeneous equations? See, girls, you have so many methods, but in your syllabus only you have altogether 6 methods. 4 of them are under direct methods. We call them as exact methods, and 2 methods are given under indirect methods, which are iterative methods. Okay, today in this class, you are going to learn how to solve the system of linear equations by direct methods. Okay, and the direct methods are matrix inversion method, Gauss elimination method, Gauss-Jordan method, triangularization method. We can also call it as LU decomposition method or factorization method. So in today's class, I would like to cover these 4 models, and you are expected to do at least 1 problem for each model, means 4 problems. So today, by tomorrow morning 10 o'clock, you have to submit at least 1 problem for each variety. Please take it seriously and do the problems for each variety, and submit them in the Google class. Okay. So now you're going to learn the direct methods of solving the system of linear equations. The very first method, actually, why we direct method, actually, it is based on the elimination of the variables, girls. So what we do is we get exact value, exact solutions in this case. Whereas in iterative methods, what happens, we always start with the initial approximate solution, and what we do is we further proceed with the same technique repeatedly to get the best approximate solution. Okay. So what we do is in a direct method, we directly go for elimination of the variables and we get the exact solution. Whereas indirect methods, we start with an approximate solution. We use the same process repeatedly, means iterative process, to get the best approximate solution. Okay. So let us move to the direct methods. The very first method in the direct method is matrix inversion method. Why we call it as exact method, I told you earlier. We get the exact solution. That's why we call these direct methods are also as exact methods. Okay. Now, let us take the given system of equations, like M equations, means 4 equations and 4 unknowns. And in this method, what you have to do is, here I'm giving you step-by-step process, girls. You follow these steps and take one problem of each variety, do them on a paper, and scan them and submit them in the Google class without fail. I'm saying once again, be serious in submitting the assignments. Anything can be taken as a final decision with regard to your result, as this outside the matter is very uncertain. Okay. So matrix inversion method, what you are doing here, first of all, you write the given system of equations in the matrix form under step 1. As I said earlier, you write the equation, take the equation 1, its coefficients you arrange in the first row. Second equation, you write the coefficients of the unknowns in the second row, and the coefficients of the unknown of the equation 3 you write in the third row of the matrix, and the last equation, the coefficients of the unknowns A41, A42, A43, A44 you arrange in the last column. This is called as coefficient matrix, which we denote by capital A. And then the solution matrix, that is here the unknowns X, Y, Z, W. It is a column matrix, and right side the constant matrix. Whatever you have on the right side, you put it as a column matrix. The very first step after taking the equations is that arrange them in the matrix equation. Okay, where A is the coefficient matrix, X is the solution, and B is the constant matrix. Your see method here is matrix inversion method. Okay, and you know very well that only non-singular matrices will have inverses. Non-singular means determinant is 0. A matrix A is called non-singular if its determinant is different from 0. Okay. So here coefficient matrix A is non-singular. So you're going to find out the inverse. You're going to find out the inverse, actually speaking, for the present, assuming that the matrix is non-singular. Okay. Now here we wrote in the first step the given system of equations as Ax is equal to B. As I said earlier, you pre-multiply both sides with inverse of the matrix. Like, once you find its determinant, it's different from 0, it is non-singular. Every non-singular square matrix will have inverse. So multiply both sides, means pre-multiply with A inverse and get X is equal to, X means the solution. Aim is to find out X. Your aim is to find out X, the solution matrix. So capital X is equal to A inverse B. So what you have to do is, first you find out inverse of the matrix. You know how to find out inverse of the matrix. This is how. Adjoint A by determinant A. How will you find out adjoint of a matrix, girls? Adjoint of a matrix is nothing but it is the transpose of the matrix of the cofactors. Okay, for every element you find out the cofactor, girls, you will get a matrix, and you take the inverse of that matrix. That would be not inverse. You, after finding out the matrix of the cofactors, you take the transpose of that matrix, which will give you adjoint of A. Okay, see, you are finding out A inverse by using this formula. Adjoint of A, determinant of A. Determinant, you know how to find out. It's a number. Adjoint of A is nothing but the transpose of the matrix of the cofactors of the elements of the matrix A. Okay, for each element of the matrix A, you find the cofactor. Like that, you'll get a matrix of the cofactors, and then you transpose that to get the adjoint of A. So A inverse you can find out using this formula. Once you have A inverse, then multiply B with A inverse, pre-multiplication. This is matrix multiplication, girls, to get the solution matrix. So I explained to you once again how to find out the solution of the given system using matrix inversion method. First step, you write it in the matrix equation form. A x is equal to B, and you check whether determinant is different from 0. If it is different from 0, the matrix is non-singular and it has inverse. What you have to do is you find out inverse of the matrix. Inverse of the matrix is given by adjoint of A by determinant of A. And how will you find out adjoint of A? By writing the first matrix with the cofactors of these elements. Okay, for every element you find the cofactors, you get a matrix of the cofactors, and that matrix you take the transpose to get adjoint of A. And then adjoint of A by determinant A will give you inverse of A. And then what you have to do, your aim is to find out X, Y, Z, W, no, the column matrix. So that is denoted by capital X. So capital X is nothing but product of A inverse and B. Okay, just now you got inverse of the matrix A, that is a matrix of order 4 by 4, and B is a matrix of order 4 by 1. When you multiply those two, you get a matrix of order 4 by 1. Therefore, from that column matrix, you get X, Y, Z, W values. And these X, Y, Z, W values will satisfy every equation, girls. And this is how you can solve the given system by using matrix inversion method. And this is for short answers. Now, let us move on to the second method, Gauss elimination method. The Gauss elimination method actually, it's not that actually means if the order of the matrix is more than 4, we better go for a better method than this. So, but we have to learn even this method also. And what we do in this method is, it is a systematic method actually speaking. What we do is we will be eliminating the coefficients. Okay, elimination of the coefficients will be done, and every time, and then from the reduced upper triangular matrix you will be getting some equations, solving them you'll get the solution. So what we have to do is, like before, let us consider a system of 4 linear equations in 4 unknowns X, Y, Z, W. Okay, and now see here A11, A22, A33, A44, we call them as pivotal elements. Why? Because see, when you arrange this system of equations in the matrix form, as I discussed earlier under step 1, it would be like this. Capital A into capital X is equal to capital B, where capital A is the coefficient matrix, capital X is the solution matrix with unknowns X, Y, Z, W. So here if you see in this matrix, this is a square matrix, this column A11, this diagonal A1 with elements A11, A22, A33, A44. The elements on the principal diagonal A11, A22, A33, A44 are called as pivotal element. We have to make use of these pivotal elements to make the other elements of those columns zeros. Okay, that is what you are going to do. So first step is what? After having the equations, you write them in the matrix form. Okay, then second step is you have to eliminate X from what? From second, third, and fourth equations. Okay, how? Second, third, fourth equations means you're going to make A210, A310, A410. How? You have to subtract A21 times of the first row from R2, and you have to subtract A31 times of first row from R1, like R3, like that. Okay, here I'm giving you the transformations. Okay, so what you have to do is, this is matrix A, this is matrix B, you consider the augmented matrix AB. Your aim is to eliminate x from the second, third, fourth equations. X is there in the first equation though. Your aim is to eliminate x from the second equation, x from third equation, x from fourth equation. Means you have to make A210, A310, A410. So by using row transformations, you make first in the step A21, A31, A410. That is what these transformations means. Okay, after the elimination of the variable x from second, third, fourth rows, you will be getting a reduced matrix. Then what you have to do in step 3? In step 3, what you have to do is you have to eliminate y from third row and fourth row. So in the first step, A11 becomes the pivotal element. Using A11, you are able to make A21, A31, A410. Whereas in the next step, A22 would become the pivotal element. With respect to that, you have to think of making A32, A420. Means you are eliminating Y from the third and fourth rows. Okay, that is the step 3. After the elimination of Y from third and fourth equations, you will be getting a reduced matrix. So in the last step, you have to eliminate Z from the last equation. In that case, the pivotal element will be the one which is in the A33 position. Okay, so what we are doing, every step you are eliminating, and that is what is called as Gauss elimination method. Okay, so once you are eliminating the variables like x from second, third, fourth equations, y from third, fourth equations, z from fourth equation, you will end up with the augmented matrix, which is nothing but an upper triangular matrix. Okay, so from which you can write the equations and you can solve them, get x, y, z values, and of course w value. Okay, I think it is very much clear. You have to do a problem on this model. Okay, so first problem is problem of solving linear equations using matrix method, and second one is solving the system of linear equations by Gauss elimination method. Let us now come to the third method, that is Gauss-Jordan method. This is just a modification of Gauss elimination method, girls. There is a systematic procedure here in the Gauss elimination method. If you have observed, what we did here, we are not using any other row transformations. Only with respect to the pivotal elements, step by step, in a systematic way, what we did here, we eliminated first x in from second, third, fourth equations. Then we are eliminating y from third, fourth equations. Then we are eliminating z from fourth equation. Okay, like that. Afterwards, you have to eliminate w. This is how you proceeded without using any other row transformations. We are only concentrating on the pivotal element. Okay, but here in Gauss-Jordan method, you need not follow that step-by-step process, girls. You can just use any row transformation, and thus you can get an upper triangular matrix to get the solution. Comparatively, this is easier method because you can use any step, any transformation anytime. There no need to follow an order like in the case of Gauss elimination method. Okay, so the elimination of the unknowns can be done with or without using pivotal element. But in case of Gauss elimination method, we have to use only the pivotal elements like A11, A22, A33, A44 to eliminate x, y, z, w. Whereas here you need not just to use the pivotal elements. That is why this is better and easier method, and it is called as a modified Gauss elimination method. Okay, and your aim is to reduce this coefficient matrix or augmented matrix in the upper triangular matrix. Okay, so you can use all elementary row transformations. What are they? Interchange of the rows and subtracting multiples of a row from other row, and then what? Multiplying a row with a non-zero element. Okay, what are the three row transformations, girls? Interchanging of any two rows, Ri changed to Rj. Second one is multiplying a row with a constant like k times of ri or 1 by k times of ri. The third transformation is you can subtract or add any row with the multiples of other row elements, corresponding elements, like ri minus k times of rj means multiples of rj, row j, you can subtract from ri. These are the row transformations, elementary row transformations. You can use them here in this method in order to reduce the augmented matrix to the triangular matrix. Whereas such provision is not there in Gauss elimination method. There you have to use pivotal element and then elimination has to be done in a systematic order way. So what we have to do, as usual, after having the system of equations, you write them in the matrix form. What is A here? The coefficient matrix. X is the solution matrix. B is the constant matrix. Now you consider the augmented matrix AB like this. Means along with these 4 columns, you will be taking this also as one of the columns. Okay. And what is your A? You have to reduce this augmented matrix into an upper triangular matrix using all type of row transformations. All the 3 row transformations means either interchanging the rows, multiplying a row, dividing a row, or adding multiples of a row to other row. Okay, like this you can use all possible row elementary transformations and reduce the augmented matrix to the upper triangular matrix. Okay, so once the matrix is an upper triangular matrix means the elements below the principal diagonal all will become 0, girls. The elements below the principal diagonal will be 0. Such matrix is called as upper triangular matrix. So your aim is to reduce the augmented matrix to upper triangular matrix by using all the row transformations, and then by multiplying with this, I mean substitute, it will be reduced, no? So then from which you can get x, y, z, w values. So this is Gauss-Jordan method. Let us go to the last method, girls. This is triangularization method, and the first 3 methods, matrix inversion method, Gauss elimination method, and Gauss-Jordan method are expected for short answers, whereas triangularization method is expected for an essay, girls. Okay, this is also called as LU decomposition method, where L is the lower triangular matrix, U is the upper triangular matrix. Okay, what we do here is we write the coefficient matrix here. So the coefficient matrix, as usual, step 1 is AX is equal to B. So what we do is A is being decomposed into product of 2 matrices. One is a lower triangular matrix, other one is upper triangular matrix. So like this you must take lower triangular matrix with elements above the principal diagonal as 0, and this is the upper triangular matrix with elements below the principal diagonal as 0. And remember, when you take the lower triangular matrix, all the elements on the principal diagonal are 1. Okay, this is how you are decomposing the matrix A as product of triangular matrices. That's why it is called as decomposition method or LU method. Okay, L for lower, U for upper. So you must remember these 2 matrices, girls. The first step is write the matrix in the matrix equation form. Second step is you must write A as product of L and U. Okay, so what you have to do, A you write here, L is this, U is this. You find the product of LU and A. When do you see the 2 matrices are equal? When they are same, when they are of same order and corresponding elements are equal. So what you have to do is, after equating A with product of these 2, you find out what is L21, what is L31, what is L32, what is L41, what is L42, what is L43. Similarly, you find out all these elements. Okay, your aim is to find out the elements L11, like L21, all these elements, girls. That you can easily get from this equation, because you know what is on the left side, you know what is on the right side. So you equate the corresponding elements of these 2 matrices so that you will get the values of L21, L31, L32, L41, L42, L43. U11, U12, U13, U14, U22, U23, U24, U33, U34, U44. And then what you have to do, you just write this. This is the system of equations. No, 2A is being written as product of LU. So in this place, you substitute LU, girls. That's what I did. LU, AX is equal to B. In place of A, I put LU. Okay, so what you have to do is next step, you find out ux as y, ux as y. Okay, ux, this is lux, so this you are writing it as y matrix. Okay, so now this is the equation 3. From this equation 3 you will get this as a y matrix now. So this equation 3 becomes 1 0 0 0 L to 1, this matrix multiplied by, in this place you are writing the column matrix y1, y2, y3, y4. So this is product of two matrices, 4 by 4, 4 by 1, you get a 4 by 1 matrix. Okay, from this you will get the value of y1, y2, y3, y4. After getting values y1, y2, y3, y4, you substitute them here, which is ux is equal to this column matrix. That's what I did here. From 4, ux is equal to y. So after getting y1, y2, y3, y4 values, you equate this. From this equation, you will get the values of x, y, z, w. I gave you here a procedure, girls. Procedure to find out the solution of the given system of linear equations. Here, 4 equations and 4 unknowns. This step-by-step process, if you follow, you can easily get the matrix, the solution of the given system of equations. So only thing is here you have to remember is first step is writing the equations in the matrix form. And then second step is writing A as product of LU, where L is the lower triangular matrix, U is the upper triangular matrix. Your aim is to find out all the elements in L, all the elements in U. So from this equation, you will get those values. And afterwards, you substitute those values in L and U. So you replace A with L into U as we discussed here. So that is what we wrote. L into U. This is A. X is equal to B. So next step is this matrix into this matrix, you rename it as column matrix y1, y2, y3, y4. So in this place, I'm substituting y1, y2, y3, y4. So this into y1, y2, y3, y4 becomes this, from which you can find out the values of y1, y2, y3, y4. After getting y1, y2, y3, y4, you substitute again in this equation, girls. Then from which you get the required values x, y, z, w. Your aim is to find out the unknowns x, y, z, w. Solving the system of 4 equations, like these 4 equations, in 4 unknowns x, y, z, w means you have to find out the unknowns x, y, z, w, satisfying all these 4 equations. And from these direct methods, matrix inversion method, Gauss elimination method, Gauss-Jordan method, and triangular method, you will be getting the exact solution, girls. Means if you substitute a solution which you got, that will satisfy all these equations exactly. Okay, that is why we call them as direct methods or exact methods. I will end up with this today, girls, and all these problems I explained in the class. We did enough revision also, and what homework I'm going to give you is you have to do for each of these 4 methods one problem and upload them in Google Class by 10 o'clock tomorrow.
Okay, ma'am.
Now, do you have any doubts, girls? Only 6 participants, including me, girls. I'm feeling very bad. That's why whatever I'm recording, I'm sharing with you all in YouTube video. Okay? Shall we close now?